All right, so the last time we were together, I told you that today we would be going over an easier way to do long division. Um, Technically, I suppose I lied just a little bit in that the long division we're going to be doing today, um, it, synthetic division is an easier way to do certain kinds of long division, I guess is the way I should have said, okay? It's an easier way to do certain kinds of long division. And you'll rapidly see what I mean. What is this? I have a fear of heights and long division. Oh, yes, yes, yes. On the psychiatrist's couch. Long division affects us all differently. All right. Now, here's a typical long division problem, okay? It's a little tricky to understand what I'm about to say. I wanted to try to justify for you just a bit synthetic division and why it works. A couple of comments to make here. First, synthetic division, what I'm about to show you called synthetic division, only works when you're dividing by an x plus 2 or an x minus 2 or an x plus 3 or an x minus 3. Essentially, you need a number here and just an x, okay? Now, that is not necessarily true, but for the scope of this course, what we're going to be doing here is simply doing it when it's a number plus or minus an x, okay? And there's a simple, really incredibly easy way of doing these problems. The interesting thing about all of this, because this is just an x, this first term, x into x cubed, because this is just an x, will always be a 1 or whatever the number was right there, okay? That's kind of interesting. So it'll always be either a 1 or whatever the number is in front of the x cubed. So that number stays the same. And then all of these successive numbers, you end up multiplying by this 2, okay, to get the 6, okay? To get to multiply by the 2, you take the 2 times the 1 to give you this, and then 2 times the 6 to give you 12, and so on, okay? The other thing that's interesting here in this is you are always subtracting, and you're always going to be changing the sign of these numbers, all right? So there's like 3 really incredibly interesting things here. First, because this will always be just an x, it will always be either a 1 or whatever the number is in front of the x cubed. The other thing is how you always end up taking the 2, this number right here, times whatever these numbers are to get these other numbers. And thirdly, you always end up subtracting, okay? Which means changing a sign. So how can we then do this problem without doing long division and using what I call synthetic division? Okay, here's what you've got to do. You make a box. It's kind of like a long division box, but it's upside down. You put all the numerical coefficients in of your dividend. So there's a 1x cubed, there's a negative 4x squared, there's a 2, and there's a minus 3, okay? Then because we always change our signs when we subtract, I'm going to change that 2 right away to a negative 2, okay? All right, so let's just stop here a second. These are the numerical coefficients of your dividend, and make sure you watch out for any missing terms. There are no missing terms in that dividend. It's a 1, a negative 4, a 2, and a negative 3. If there were missing terms, you have to put a 0 in there. X plus 2, change it to a minus 2. A couple reasons why you do that. The first is because of subtraction. You always change the sign and add. The other way is if this is a factor, and you're solving this equal to 0, wouldn't you set it equal to 0 and get negative 2 anyway, right? All right, so now we've got it all set up for long division. By synthetic division. Draw a line here, okay? Bring your first term down. Just drop it down. It stays the same, remember? Whatever is here is going to go here. If it's a 1, it stays a 1. If it's a 5x cubed, it's a 5x squared. So you just bring this term down. And now the rest of it's easy. You multiply, as I said. Remember how you always multiply the 2 times the numbers? Okay, so here we go. So we have -2 times 1 is -2. Add is -6. Okay? -2 times -6 is 12. Add is 14. -2 times 14 is -28, and you end up with a -31. All right? Now, notice 1, -6, 14, and -31. That's incredible. All right? Now, since you're dividing by an x, this will always be an x. This term up here will always be a 1 less exponent than what it started with. So since we were dividing into x cubes, you don't even have to look at that. You know this is 1x squared minus 6x plus 14, remainder -31 over the divisor of x plus 2. Okay? And you get your answer that quickly. For an x plus a number or an x minus a number, this is incredibly easy. Okay? Here's another synthetic division problem with all the steps. You're dividing by x plus 3, so you make it a -3. Change that sign right away. Here's all your coefficients: 2, -5, -1, and 3. Drop the 2 down, whatever it is. Okay? Multiply. -3 times 2 is -6. Add them, -11. -3 times -11 is 33. Add them, it's 32. -3 times 32 is -96. Add it is -93 for the remainder. You started with an x cubed, so you drop it down to 2x squared. 2x squared minus 11x plus 32 plus the -93 over the x plus 3. Okay? It is that easy. All right, so let's try some synthetic division. Okay, first one here should be easy. Make your long division box upside down. I have 1 minus 5 and 4. Change the sign to 1. Okay, drop this 1 straight down. 1 times 1 is 1. Add. 1 times -4 is -4. Add. And 0. This one came out even. Okay? This one came out even, so whenever you're dividing x minus 1 into this, your final answer, drop this power down 1 to get this term. It's 1x minus 4. Okay? That means that this is a factor of that because it came out even. No remainder, 0 remainder. So if you were asked to factor that, what are factors of 4 that add up to 5? Isn't it 1 and 4? There's your 1, there's your 4. Right? Checks perfectly. Next one. Make your long division box. Change a sign of the 5. Put the numerical coefficients. Now, this is in a lousy order. You see it? The cubic should be first in descending order. So I put the 3 first, -12, then -9, and 1. Draw the line down here, drop that straight down, and now you're ready to go. 5 times 3 is 15, add is 3. 5 times 3 is 15, add is 6. 5 times 6 is 30, remainder is 31. So what is your answer to this division problem? The highest power was a 3, so this drops down to 3x squared plus 3x plus 6 plus a 31 over the x minus 5. Long division with synthetic division. It doesn't get any easier than this. All right. Let's try this one. Make your long division box. Notice here we have a missing term. So I have 4, then a 0 for the missing term, and then a -3. Change the sign of the 5 to -5, draw the line. 4 comes straight down. Multiply. Add. Multiply. remainder of 97. Drop your power by 1 because you're dividing by x. So I'm going to have 4x, okay? Then minus 20 plus 97 over x plus 5. Okay? Synthetic division. Now, there's something that really is kind of odd and kind of beautiful at the same time, and it's illustrated here in the remainder theorem. If you're dividing a big long polynomial by an x minus a number, that's what we're doing in synthetic division. X minus or x plus a number, okay? It implies that the remainder is equal to the functional value of the number. Whoa. What does that say? That says if you want to find p of a half, the functional value, p of a half, don't you have to stick a half in here? Okay, let's do it. A half squared is a half times a half is a quarter, times 2 is 2 quarters. A half times 9 is 4 1/2, plus 1. This is a half, plus 4 1/2 is 5, plus 1 is 6. The remainder theorem says if you don't feel like sticking that 1/2 in there, okay, all you have to do is do synthetic division on the half. Do synthetic division on the half. It's already changed. It's no longer x minus 5 or x minus 1 or x plus 5. This is a half, okay? So I want to do synthetic division on the 1/2 and take your coefficients, 2, 9, 1. Drop the 2 straight down is 1, 10 is 5. Look at that. Isn't that weird? Okay? And if you don't feel like putting the number in, you can simply do synthetic division. But remember that the sign has already been changed. You don't have to change the sign. All right. How about the next one? Now look at that one. Putting 11 in. I'm going to put it in. It's just a royal pain in the neck here. Okay? So I have 2 times 11 cubed. All right? Minus 21 times 11 squared, plus 11 times 9 is 99, and then minus 200 equals, and I get a final answer of 20 by putting 11 in. Now the remainder theorem says what I could have done was simply done synthetic division on 11 and my coefficients 2 minus 21, 9 minus 200. Okay, let's see what happens. Drop the 2 down. 22, that's 1, that's 11, that's 20. This is 220, 20. Bingo. Exactly the same thing. All right. You know, I have taught pre-calculus for an awful long time. All right. But still, I about half get goosebumps when I see the remainder theorem. That is just so interesting, the reason that that works like that does. Ah, great stuff, great stuff. Should have charged admission for class today. All right, how about this one? Here we have a big, long, ugly function. Show that 1/3 and -2 are zeros. Remember what a zero is. A zero is some x value you put in and you get 0 out. Okay? Now we just talked about that. If I put 1/3 into this function, that's finding p of 1/3, right? Which is the same as the remainder if I do synthetic division. Another way of thinking about this, if you know that 1/3 is a 0, if you know that x equals 1/3 and -2 are zeros, don't you know, let's work backwards. Don't you know that x minus 1/3 and x plus 2 are factors? Isn't that the way we work? Right? Okay. So if we want to show that those guys are zeros, we want to put them in and get 0 out, or we want to do synthetic division and get a remainder of 0, which would mean that they're factors. Either way you look at it. All right, so we want to do, let's do a third first. Box, coefficients, 3. Any missing terms? No. -1, -21, -11, 6. Here we go. Drop this 3 down. A third of 3 is 1. That's 0. That's 0. That's -21. That's -7. That's -18. That's -6. Bingo. Okay. We got a remainder of 0, so we know that 1/3 is truly a 0, and x minus a third is a factor. Now we have to do it for -2. So let's do it for -2. Drop a 3 down. Is -6. Is -7. Is 14. Is -7. Is 14. Is 3 -6. There it is again. Okay, we have shown that 1/3 and -2 are zeros. Okay, by the way, we have been hunting zeros over the last couple of class periods. Some of you might be sitting there saying, wait a second, I think I see where he's headed here. We are now finding a new way to find zeros of some very complicated looking polynomials. I mean, who in their right mind would want to try to solve that for 0? That's incredibly difficult. All right, incredibly difficult. All right, so you might see where I'm headed here over the next class period or so. Show that x minus 1 is a factor. If it's truly a factor, it's going to divide evenly and have a remainder of 0. So here we go again. Now remember, once again, this only works when you have x minus a number or x plus a number. Throw another number in front of the x, and you can't do a synthetic division. That's where we are right now. All right, so you change the sign to a 1. Put the coefficients in. 1, missing term, missing term. See, there's no x squared term. -7 and 6. Drop the first number down as 1, 1, 1, 1, -6, -6. There it is. Okay, it's a factor. By the way, what's the other factor? X minus 1 is one factor. What's the other factor? Is it not 1x squared? You drop your power by 1 plus 1x. There's the other factor, right? There's the other factor. There you factored it into 2 parts, okay? And you might say, aha, there's another way we might be able to factor things. You are indeed correct about that. Okay, homework. For the second day on section 3, remember I broke it into 2 days to try to make things a little easier for everybody.